Hello, in this video I'll be showing you how to answer the NSAA 2016 Section 1 Question 45. Which two of the equations represent redox reactions? So let's take each equation in turn. So looking at equation 1, we have chlorine gas plus potassium iodide goes to iodine gas plus potassium chloride. So let's work out the oxidation state of each element. So starting with chlorine gas, the chlorine here has an oxidation state of 0. You can think of this as having a Cl plus and Cl minus, where you have an average of the plus 1 and the minus 1, which gives an average of 0. Next, looking at the potassium iodide, the potassium always has an oxidation state of plus 1, it's a group 1 metal, and iodine here will have an oxidation state of minus 1. Now looking at iodine gas, this is the same as chlorine gas, so I have an oxidation state of 0. And for potassium chloride, it will be exactly the same as potassium iodide. Potassium has an oxidation state of plus 1, and the chlorine will have an oxidation state of minus 1. So we can see here that the iodine goes from minus 1 to 0, which is an oxidation, and the chlorine goes from 0 to minus 1, which is a reduction. So this is a redox reaction, as both oxidation and reduction are happening. So equation 1 is correct. Now looking at equation 2, we have chlorine gas plus 2 electrons goes to 2Cl minus. So here, in the chlorine gas, again, chlorine has an oxidation state of 0, and here, in the anion, it has an oxidation state of minus 1. So you have chlorine going from 0 to minus 1, which is a reduction. However, we do not have oxidation, nothing's been oxidized here, so this isn't a redox reaction. So equation 2 is incorrect. For equation 3, we have HCl plus silver nitrite goes to silver chloride plus nitric acid. So looking at HCl, we have the hydrogen has a plus 1 oxidation state, and the chlorine has a minus 1 oxidation state. Now the silver nitrate, silver has a plus 1 oxidation state, and the silver nitrate has a minus 1 oxidation state. Looking at silver chloride, silver has a plus 1 again, and chlorine has a minus 1. And for nitric acid, the H has oxidation state of plus 1, and then NO3 has an oxidation state of minus 1. So here there's no oxidation or reduction, everything stays at its same oxidation state, so there's no redox. So this implies that equation 3 is incorrect. Now finally, equation 4, we have chlorine gas plus water goes to HCl plus HClO. So for chlorine gas, we know that chlorine has an oxidation state of 0. For water, H has an oxidation state of plus 1, and oxygen has an oxidation state of minus 2. HCl, H has an oxidation state of plus 1, and chlorine has an oxidation state of minus 1. Now finally for HClO, H has an oxidation state of plus 1, and oxygen has an oxidation state of minus 2. Therefore, the oxidation state of chlorine, to balance out, has to be plus 1. So we can see the chlorine goes from 0 to minus 1 in HCl, so we have a reduction. But we also have a chlorine going from 0 to plus 1 in HClO. So this is an oxidation. So we have both oxidation and reduction, so this is a redox. So equation 4 is correct. So looking at our options, we know that 1 and 4 are correct, so the correct answer is C.